This last problem asks us to find the area of triangle ABC. Now, we know two things. We know that we can find the area of a triangle simply by multiplying 1/2 times the base times the height. But finding the area of a triangle when you're not exactly sure how many units make up the base and how many units make up the height because your triangle is slanted is much more difficult. So we need to use some additional information that we can understand in order to find the area of this triangle. And so what I actually want you guys to see are all of the little triangles that are within this large rectangle that we made to encompass or surround this triangle that we're looking for the area of. So we've got one triangle here. We've got another triangle right here that we're trying to find the area of. So we'll call that 2. We've got a final triangle right here, and we'll call that 3. So we're going to find the area of those 3 triangles and also the area of the rectangle in general. And then we're going to subtract that information from the area of the rectangle so that we can actually find the area of this triangle in the center here. And I know that seems like a lot of work, and it would be really nice if we could just go ahead and find the area of that rectangle in the middle. But since it is slanted, it's a lot more difficult to do. So we're going to do it this way in order to really find the area of this rectangle. All right, so we've got area, or we're going to break this up. So I'm going to say rectangle number 1 or triangle number 1. We're looking at 1/2 times, let's count the base. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units making up the base of this triangle. So multiplied by 11. Ruby, no. Okay, and then we have 1, 2, 3, 4, 5 units making up the height of this triangle. So we're going to multiply that by 5. So now we're going to find the area by 1/2 times 11 times 5 is 55. And half of 55 is 27.5 units squared. 27.5 units squared. So there is the area of our first triangle. So I'm going to break this up so that I can find the area of the other triangles. So let's now look at the area of the second triangle. So we have a base of, let me see the second triangle, we've got a base of 1, 2, 3, 4 units. So here's 4 units. So 1/2 times 4 times the height of our triangle is 1, 2, 3, 4, 5 units. So we've got 1/2 times 4 times 5 is 20. So the area of our triangle, half of 20 is 10. So the area is 10 units squared. And then we need to find the area of our third triangle. Whoops, sorry. The area of our third triangle. So the base of our third triangle is a little bit larger. Come on, pen. There we go. So we have, let's see, 1, 2, 3, 4, 5, 6, 7 units making up the base of that triangle. So 1/2 times 7 times the height of this triangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units times 10. So I have 1/2 times 70 now, and half of 70 is 35. So the area of that triangle was 35 units squared. And now what I need to do is find the area of the rectangle. And remember, I'm going to erase all this so we can actually see the rectangle. The area of the rectangle is simply base times height. So the area of my rectangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units along the base. So we've got 11 times, and I've got a height of 10 units because I just found the height of this rectangle right here. So 10 units. And 11 times 10 is 110. So the area of my rectangle is 110 units squared. Okay, now since I'm trying to find the area of this triangle inside of all of this other mumbo jumbo, what I'm going to do is I'm going to take the area of the bigger piece. So that is the rectangle that is surrounding this small triangle. And I'm going to subtract from the area of that rectangle the area of these smaller triangles. So minus 27.5, minus 10, minus 35. And when we carry out that operation, we get that the area of that triangle is 37.5 units squared. And that was simply by subtracting 27.5 from 110 and 10 from that and 35 from that. And we get 37.5. So if we were to count the number of units inside this triangle right here, we would see that there are 37.5 units within that triangle. So we represent this, the area of this triangle as 37.5 units squared. So even though we do understand how to find the area of a triangle, because this triangle is slanted, we need to find the area in a different way than by simply using our area formula. So just one more time, I want to go through those formulas with you guys. So I'm going to open a new page. And I really want you guys to write these down if you did not previously. So area formulas. I want us to remember these because these are really important for your homework. So remember, we looked at parallelograms. Parallelograms were those slanted rectangles that we looked at. And remember, we find the area of a rectangle simply by multiplying base times height. So we do the same thing for a parallelogram. So I'm actually going to write the area of a rectangle just below the area of this parallelogram, which is also base times height. We've looked at a triangle many times, but we find the area of a triangle by 1/2 times base times height. We did not look at a circle today, but we have looked at a circle in the past. And remember that we find the area of a circle by pi r squared, and where r is our radius. And then we find the area of a trapezoid. So remember when we have two bases, a trapezoid, and I'm actually going to draw you a trapezoid. So remember when we have a shape that looks something like this. That is a trapezoid. So we've got two bases. We've got base 1 and we've got base 2. Remember that we find the area of that trapezoid by 1/2 times base 1 plus base 2 multiplied by the height. So remember, that's how we find the area of a trapezoid. Okay, so now that you guys are familiar with, and we've been through all of these area formulas and we've looked at all of these different shapes, what I want to do, or I want to see, is if you can complete the problems on the exit ticket and the problem set based on the information that I've just shown you. So I don't think you should have any trouble with these problems, but of course, if you do, please do send me an email. I'm always happy to help. So I'm going to stop this.